4B. There is a 6-5 in this chapter, but we do skip it. It's the trapezoid ones, and we already kind of talked about that. Finding the area using trapezoids instead of, yeah, so we don't need to do that. Okay, so this is going to be an area connection. So we know that the integral measures the area under a curve. Like, for example, if you had the integral from 0 to pi of sine x dx, right? And if you looked at that, and no, that would be cosine, right? So 0 to pi for sine, the sine wave looks like this. It was 2. Yeah. So what you do is you want to find the area from 0 to pi, the area between the curve and the x-axis. And what you're doing is you're finding this area here, which so happens to be 2. And you can do that using antiderivatives. You can do it on your calculator using f and int, right? You can do all kinds of things. Okay. So what we're going to do is there's a connection to the area and the integral. But if I want to find the area of something and it's underneath, I have to do the opposite. We talked about this a little bit before we went to spring break when I accidentally taught that to you and shouldn't have. So here we go. Number 1. Suppose you have y equals x squared minus 2x on the interval from 0 to 3. Okay? And they'll give you a picture of it. They'll show you what it looks like. So there's a parabola. And the zeros of this parabola are, what are they, 0 and 2? Yeah. 0 and 2. And so this parabola, it dips under and it goes like this. Okay? And the area that they want you to find, they have to tell you what the area is that they want you to find. You have to find the area of that and this. That's the area they're looking for. Okay? In order to find that area, you can't simply just take the integral from 0 to 3 of this function. You can't, because it's going to give you a negative for there and a positive for there, and it gets them out.
Oh, we already learned it. So
yeah. Right. So what you want to do is you want to integrate from 0 to 2, x squared minus 2x dx, and take the opposite of it, because it's going to give you a negative area, a negative value. Take the opposite and then add it to the area from 2 to 3, x squared minus 2x dx. Okay? And you can do that by hand. They let you use fint if you want to, f and int. You can do it either way. So let's remember how to do that. Now, if you have an older calculator, you know, it's not as nice because it doesn't give you the actual integral symbol. So if I do alpha window, oh, you know what? I'm going to go back to function mode. Hi, welcome back. So I go to alpha window, I go to fint, and I can go from 0 to 2 of x squared minus 2x dx. And I should expect a negative answer, right?
Absolutely.
Yes, I get negative 4/3. Perfect. So I'm going to change that to positive 4/3, and then I'm going to add it too. Now you know you can do this, right? You can hit second enter and then just change the interval. You know you can do that, right? 2 to 3. Sure. And you get, oh, take a look at that. 4/3. Whoa, both those areas are 4/3. Isn't that cool? It is. That should be really interesting to you. So what would the integral of this be if I were to just take the integral? It would have been 0, huh? Yeah, but the area of it is 8/3. So the total area of the red region is 8/3. The integral from 0 to 3 is 0. Very interesting. Now, the other way to do this, there's what? Oopsie whoops. Math goosebumps. Yes, math goosebumps. I love those. The other way to do it would be to kind of trick your calculator a little bit. You could, if you wanted to, use f and int and do this. The integral from 0 to 3 of the absolute value of x squared minus 2x dx. You know what that does? It flips everybody to positive. Well, because I wanted to show you the hard way first. We have to learn the awful way first. No, if you were to graph this, it would look weird. It would go like this, and it would go like that, because it flips everything to the positive, and so it will give you the correct answer now. Isn't that neat? Just say yes. Okay.
It's like half of a fish.
Yes. So if you hit second enter, and you change this to 0 to 3, and then you make this, oh, I don't think it's not gonna work, huh? Math, absolute value. No. Okay, totally messed up here. All right, so let's try that again. F and INT, 0 to 3.
No, you have to do absolute value.
Math, absolute value. And what was it? X squared minus 2x dx. Perfect. And it should give me 2.6 repeating, which is 2.6 repeating. Your calculator actually, it has a yeah. 8 divided by 3, 2.6 repeating. It is a little bit off. You know why? Because this calculator has a program of how to do this, and it's actually, the program is finding like little rectangles. It is like, I don't know for sure. I made that up, but I'm thinking that's what it does. It's estimating it.
Wait, so if we wrote if we did not recognize that was
yeah, 2.6, and then okay. All right, number 2. Now here's kind of an interesting one. It tells you to integrate or find the area under this curve. And it'll give you a picture. And it has, this is 1, 1. And it looks like this. Hi, Kevin.
Oh. So much cooler in here. Good job. Don't recognize Jack. Hi, guys.
Too.
Hey, Jack.
Oh, hey, Jack. Didn't see you there. Okay, so this right here, it's two. It's 2 equations in one. No, it's 2, 4 actually. Let's go up a little higher. There we go. That doesn't really matter though. Okay. So what they want you to do is they want you to find the area under the curve from 0 to 2 of this weird looking thing, and they will tell you the equations that they are. So this first one right here, there's like 2 separate functions. This is y equals the square root of x. And this one over here is y equals x squared. So it's like 2 functions put together. It's like a piecewise function. Don't you love piecewise functions? No, me neither. Okay, so what you're going to do is you're just going to do it twice. You're going to do 2 separate ones. You see that, Jihoon?
No.
Okay.
It says square root of x.
Square root of x, yeah. Oh, yeah, it looks really bad, huh? There you go. That's better. Okay. So to integrate this or to find the area, you would find the area from 0 to 1 of the square root of x dx plus the integral of 1 to 2 of x squared dx. And you know, I'm okay with you using your calculator on this. If they do say find it using antiderivatives, then you have to. Have we ever found the antiderivative of the square root of x before? It's probably really ugly, right? X to the 1/2. Wait, 3 halves, right? And then divided by 3 halves or times 2/3, probably. 2/3, yeah.
Yeah, sure.
You're just agreeing. Okay. All right, so let's go ahead and find this one. So use Fint in your calculator. Why not, right? Alpha window. And we're going to go from 0 to 1 for the square root of x. Oopsie. Where's Hannah? Whose phone keeps dinging? Trevor?
Why look at me?
Your drugs are ready.
It wasn't me.
It wasn't me. Who do you think you are, Shaggy? All right, 2/3. I got 2/3 plus 1 to 2 x squared dx. And it happens to be 2 1/3. So can you add up 2/3 plus 2 1/3?
Yeah, you can.
No.
It's exactly 3. Isn't it amazing when these things...
Isn't it amazing when they
It's not a 21. It's 2 1/3.
No, it's 2/21, so you go straight across.
So funny.
Okay, last part. Here we go. This one's terrible. Why
Crazy
are
how
we
they
doing
just choose the one.
Okay, number 3. This is different. This is not an area connection. It's just kind of a weird one that they threw in at the end. It says that the integral
Wow, Kevin.
the integral from a to x of f of t dt plus k is equal to the integral from b to x of f of t dt. All right, so that's given to you. You're like, great, yay, let's use that. And then they'll tell you that f of x is x cubed plus 3x, okay? And that a is -3 and b is +4. And our job is to find out what k is.
7.
I don't think so. This is going to be really complicated. Okay. So I'm going to walk you through this whole thing. All right, so we're trying to find out what k is. K is right here. This is what it is. It's inside this whole big thing. So let's start by solving for k here. All right? Bless you. All right, so here we go. We're going to solve for k by subtracting this integral over to the other side. Are you okay with that? So we get k equals negative a to x f of t dt plus the integral b to x of f of t dt. All right, so far so good. We're doing great. Now, here's the thing. We can make this negative integral from a to x. What can we make it? Positive from x to a. So let's do that. So k equals positive integral from x to a for f of t dt, and then we still have plus b to x f of t dt. So far so good? Okay, now this is kind of a weird way to write this. If you were to rearrange this stuff, you could write this like this. B to x of f of t dt plus, we're just going to switch them. We're going to use the commutative property that says that we can switch them because you'll get to see it better. X to a of f of t dt. Now, if I'm integrating from b to x and then x to a of the same function, what am I really integrating? B to a, exactly. We're integrating from b to a of f of t dt. Okay. All that work, we haven't even plugged in the function yet. So let's go ahead and plug it in now.
X that or is it f of t?
Well, now it's going to be f of x. We're going to plug it in. We're going to do it with x instead because it is a to or b to x and x to a, so we want to use x's. So k is going to equal the integral. So what's b? B was 4. A is -3 of x cubed plus 3x dx. Okay? Yeah. Do you want to just do that, or do you want to find the antiderivative? Just use your calculator. We'll just use the calculator. You guys are pretty good because I am going to have some on the test on Friday that you have to find the antiderivative and do it that way.
We'll review that tomorrow.
But I think we'll review in the block on Thursday, right? All right, 4 to -3, x cubed plus 3x dx. Enter. Negative 54.25. I wasn't expecting that. So I don't have the answer on my paper.